Hello everyone, welcome to Chemistry EduHub channel. Today we are going to talk about the third theory of acids and bases, that is Lewis theory. This was proposed by Lewis to overcome the drawbacks that was set by the earlier concepts. So according to him, an acid is a substance or a chemical species that can accept a pair of electrons and forms coordinate covalent bond. Now what is a coordinate covalent bond? It is a bond formed by sharing of electrons, but only one atom gives a pair of electrons where the other atom shares it without any contribution. So out of the two electrons, one element gives two electrons, the other gives none. So acid is something which accepts a pair of electrons. What is base? Exactly opposite of it, that is donates a pair of electrons. Obviously when something is there to accept, the other has to donate, or when something is there to donate, the other has to accept. Then what is salt? It is the addition product or the combination of addition product of the reaction between acid and base. So whenever you react an acid and base, whatever the final product you're going to get, that is nothing but the salt. So whenever there is a talk of salt, you need to talk about the neutralization reaction. So let us see an example here. Here we are taking ammonia. So for a neutralization reaction, in case of Lewis theory, you need a electron pair donor, that is ammonia here, and you need an electron pair acceptor, that is boron trifluoride, BF3. This is an acceptor because it has a vacant orbital, and ammonia is a donor because it has an unused pair of electrons or the lone pairs on the central atom. So what do we observe here? This lone pair will be transferred to boron, and that results in the formation of coordinate covalent bond between nitrogen and boron. So such process is considered to be neutralization according to Lewis theory, where one lone pair will be transferred from donor to the acceptor. So let us see which all substances or species can be considered as Lewis acids and Lewis bases. So you can take simple cations except for 1A and 2A group elements. 1A and 2A group cations will not be included under Lewis acids, but rest of the cations like Fe2+, Fe3+, zinc plus 2, these cations can be considered as Lewis acids. And the molecules in which the central atom with incomplete octet, for example, if you see boron trifluoride, just now we have seen, where the central atom is boron, it is with only 6 electrons, that is less than 8. In such case, to get the octet configuration, what they will do? They will act as Lewis acids. And the molecules containing double bond between the heteroatoms, suppose if you see nitrogen dioxide or sulfur dioxide or carbon dioxide, it is the double bond between carbon and some other element, or sulfur and some other element, nitrogen and some other element. So we call them heteroatoms. Those molecules can act as Lewis acids. The molecules which can expand their octet, for example silicon tetrafluoride or tin tetrachloride, where the tin silicon, they have d orbitals in them and can accept a pair of electrons can expand their octet. Such molecules can act as Lewis acids. These are the few set of molecules which can act as Lewis acids. If you look at Lewis bases, all the anions, there is no exception here. So all the anions which have negative charge on them can act as Lewis bases, like OH minus, Cn minus, Cl minus, O minus 2, etc. All the anions can act as Lewis bases because of their negative charge. They can donate a pair of electrons. And the molecules that have lone pair of electrons, at least one lone pair or more than one lone pair should be there on the central atom. So then only the substances can act as Lewis bases. For example, water molecule which has 2 lone pairs, ammonia which has 1 lone pair, and alcohols, amines, etc. which has more than 1 lone pair can act as Lewis bases. And the multiple bonds between carbon atoms. So between carbon atoms, if there is a double bond, you call it alkene. If there is a triple bond, you call them alkynes. So because of their multiple bonds, they can donate this pair of electrons and can act as Lewis bases. So these are the few set of molecules which can act as both Lewis acids and Lewis bases. So as every theory definitely possesses some limitations or drawbacks, this theory also has a few where it failed to explain the strength of acids and bases. So based on the postulates given by Lewis, we cannot differentiate which is a strong acid and which is a strong base. That is the first drawback. Generally, acid-base reactions are very faster, they happen very quickly, but the Lewis acid reactions are very slow or slow. Why is it? The reason was not explained by Lewis. And it failed to explain the neutralization reactions where there is no coordinate covalent bond. So this theory applies or can explain the neutralization only in those molecules which has the coordinate covalent bond. But the molecules or the reactions where there is no coordinate covalent bond, it failed to explain. The continuation failure is the HCl and H2SO4. We know that HCl and H2SO4 are strong acids, but according to Lewis, they cannot form coordinate covalent bond but with bases. But how are they able to show the acidic behavior was not explained. So these are the main drawbacks of Lewis and the postulates and the theory. So I hope this video is helpful to you all. Thank you.